Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. Why is North Pole colder than the tropical and subtropical regions? This question might sound silly. Everybody knows that North Pole is colder than the lower latitudes. But why? Would you know how to answer that question? If not, do not feel bad, because the answer is more subtle than many people might think. And it's even more mysterious question if I tell you something that you already know. And that's that when we have summer in the northern hemisphere, then over North Pole we have 24 hours of sunshine. So how is it that the region where the sun shines for 24 hours is colder than the regions south of North Pole where the sun shines for less than 24 hours? And that's what we will discuss today. To make topic even more interesting, I will plot here a graph that shows latitude on the x-axis in the northern hemisphere. So let's say here is equator 0, here is 30 degrees north, here is 60 degrees north, and here is 90 degrees north. And on the y-axis I will plot insolation, and I will tell you what it is. What is insolation? It is incoming in solar radiation accumulated over some period. And here the period will be 24 hours. And I will plot this figure for the first day of summer, or summer solstice, 21st June. So incoming total solar radiation on the 21st June as a function of latitude. And this curve is the curve that represents top of the atmosphere. So you can see indeed at the top of the Earth's atmosphere, North Pole receives more radiation over 24 hours accumulated than the lower latitudes. And yet, North Pole is colder than the lower latitudes. Now, to answer our question, why is that the case, we can plot the same curve, but at the Earth's surface. And at the Earth's surface, the curve might look something like this. In other words, the amount of accumulated solar radiation, insolation, at the surface, at the North Pole, is much smaller than in the tropical and subtropical regions. And this is why North Pole is colder than these lower latitudes. But of course, this is an unsatisfactory answer, because you will say, but why is this curve different than that curve? So what we need to explain now is why this curve has increasing trend and then it starts decreasing, whereas this curve over here is constantly increasing. Well, to answer this question, we will consider the geometry of our planet with respect to the incoming solar radiation. Here is half of our planet Earth, and here are two incoming solar rays. We consider them to be parallel because sun is very far away. And as you know, when we have summer, these are now important technical details. On 21st June, when we have summer in northern hemisphere, North Pole, that is maybe here, is inclined towards the sun. So North Pole is here, South Pole is somewhere here. This is how the Earth's axis of rotation looks like. North Pole. And the equator is, let's say, somewhere here. And you know from my other videos that this angle of inclination is 23.5 degrees. Now, the Earth has atmosphere that perhaps can be schematized like so. What we need to examine to answer this question is what is the thickness of the atmosphere in the direction of sun rays. Look at the equator. At the equator, or rather in the tropical regions here, this is the thickness of the atmosphere in the direction of sun rays. But in high latitudes, such as polar regions, this is the thickness of the atmosphere in the direction of incoming solar rays. It is very clear that the blue line is longer than the red line. In other words, sun rays in high latitudes need to traverse longer distance through the atmosphere than in lower latitudes. And because of this long distance, there is much higher chance of these sun rays being backscattered into the space, number one. Number two, being absorbed in the higher regions of the atmosphere. And number three, being absorbed or scattered by the clouds, again, back into the atmosphere. And these reasons contribute to the factor that less solar radiation is reaching the surface in high latitudes than in lower latitudes. And therefore, high latitudes are less warmed than the lower latitudes, explaining thereby this decrease of the red line with respect to the black line that represents top of the atmosphere. Reason number two is also associated with the type of the surface in around North Pole, and the same argument holds for the South Pole when we have summer over the southern hemisphere. Namely, around North Pole we have a lot of snow and ice, and snow is very good at backscattering light in the visible spectrum. So that means even the light that reaches the surface has a very high chance of being backscattered into the outer space, and therefore not being absorbed by the surface, increasing latent heat, increasing sensible heat. Whereas the type of the surface in the lower latitudes is very good at absorbing solar radiation, so there is smaller chance of radiation being backscattered by the surface. And I would also like to mention that this influence of clouds here is very important, because when we have summer in the northern hemisphere, these regions are very rich with clouds, so a lot of solar radiation is backscattered by clouds. And that explains discrepancy between these two curves. Indeed, accumulated over 24 hours, the amount of radiation at the top of the atmosphere is just almost linearly increasing with the latitude, but that is not the case at the surface because of the reasons I discussed. Another thing you might ask is, why is this is bonus question. Why is the maximum at 30 degrees? Why is the maximum of insolation at the surface at 30 degrees and not at somewhere here at 23.5 degrees? Now you might ask, but why would it be at 23.5 degrees? Well, look, this inclination is 23.5 degrees. So as you know from my previous videos, on 21st June, this latitude of 23.5 degrees, which is known as the Tropic of Cancer, receives highest amount of solar radiation at the top of the atmosphere. In other words, the surface is perpendicular to solar rays. So why is maximum not here, but the maximum is more north at 30 degrees? The reason is the following. If you look at the geographical maps of our planet, you will see that most deserts are around 30 degrees north. And deserts are associated with very small amount of clouds. So again, there is no clouds to backscatter radiation. And a lot of radiation is reaching the surface, thereby increasing the temperature of the surface and consequently the atmosphere. Whereas at 23.5 degrees, we have much more clouds in the atmosphere. And although indeed insolation is higher, the angle, of solar radiation with respect to the surface is higher, the highest 90 degrees in the Tropic of Cancer, less radiation is reaching the surface than in higher latitudes at 30 degrees where we do not have clouds. That's reason number one. And reason number two is that length of the day as we move north is increasing. So the length of the day at 30 degrees is longer than the length of the day at 23.5 degrees, and therefore the accumulated sunshine over 24 hours is larger at 30 degrees. Now, of course, the length of the day is further increasing as we go north, but the other factor, and that's the distance of the sun rays travel through the atmosphere, is also increasing, which contributes to backscatter, and that factor starts dominating, thereby decreasing this curve. Now, in this video, you learn so many things that maybe sounded before trivial, but you see, they are very sophisticated. Please make sure to like and subscribe, share this video with your friends and family and enemies, and until next video, goodbye.